All right, hopefully you had a little bit of a time to look at these next two problems, but these are the three forms of a quadratic that we were just talking about. We weren't talking to them, we were talking about them. So the standard form right here will give you the y-intercept, 0c is the y-intercept. The second form is the factored form. And here, this means if you have a number m and a number n, those are going to be your x-intercepts. So right here, you have x-intercepts. And then the last one is the vertex form. So we were talking about how you take the opposite of the h value, and that's going to be your x-coordinate. And then k by itself, without changing the sign, is the y-coordinate. So this is x, y. These are all xy coordinates. That's why they're in ordered pairs, okay? This is your x is 0, y is always going to be c in that standard form. Okay, so now the other thing to notice is our parabolas were opening, in the last example that we just looked at, they were all opening downward. Does anybody know from those equations, let's look back for a second. Does anybody know what about the equation said that the parabola would open downward? Because a lot of times you see parabolas opening upward. They can either open upward or downward. Do you know what about the equations here would make the parabola frowning face? A is negative. The leading coefficient is negative. So that's what we're talking about here. This says, recall that if A is greater than 0, meaning it's a positive number, right? If A is positive, then the parabola will open upward. If A is less than 0, aka negative, the parabola will open downward. Recall that the axis of symmetry goes through the vertex. So the axis of symmetry is actually x equals h. That's the very first part of your vertex. So all of these are written in vertex form. Let's find the vertex and determine if the parabola will open upward or downward. So first thing to determine is the vertex, right? So who can tell me the vertex for that parabola? 3, 2. 3, 2, because here's h, here's k, right? We have minus h, x minus h squared plus k. That's our vertex form. And then what will the axis of symmetry be? Is going to be x equals 3, okay? And I already did take the time to graph this on my device. So let me go back here, and I'm going to get rid of these first 3 and check it out. I think, oh, did I put the right one in? Is that the one? 3, 2? Yes, good. Okay. And notice that the parabola is opening upward or downward? Upward. Okay, and that's because what is A equal to in this case? What's the number that's in front of the vertex form? It's 1, and that's positive. So that means it's going to open upward. Okay, so, and then you can actually see, if I type in x equals 3, you get this axis of symmetry. This is not part of the graph itself, but you see that it's actually cutting the parabola right in half, and it actually has to go through the vertex. When the parabola opens upward, the vertex is a minimum point or a maximum point? A minimum point. A minimum point because it's the smallest part of the parabola. The parabola goes down, 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 stops at the vertex, and then turns back around. I don't know if it really stops, but it turns, it changes. All right, so if we were going to sketch a graph of this, it's not actually going, from this form, we cannot see the x-intercepts, but there was no x-intercepts here. There was a y-intercept, so it went down and around, and then we had this vertex here of 3, 2. It's opening upward because we said A is equal to 1. Since A is the coefficient in front of the vertex form, A is equal to 1 in that case. Okay, what is the vertex of the next one? It's going to be 4, 2. And this parabola is going to open upward or downward? Downward. And you say downward why? Yes, a is equal to negative 0.5. Can't really see the decimal very well because of there's no 0 in front, but we could call it 0.5, negative 0.5. And then, what's the axis of symmetry? X equals 4. So if I go to my device again, wake up device, and if I select that parabola, you can actually see that x equals 3 is not cutting the parabola in half. So I would want to change that to 4. How do I do that? I have to delete, but I went the wrong way. Okay, delete and write x equals 4. And by the way, even if you just hover and click, you can actually see they will usually highlight for you some of the key points. So there's your x-intercepts, there's your y-intercept, and there's your vertex. Okay, so if you write down, take a moment to sketch the graph, and why don't we go ahead and label all of those points? Because really what we're talking about is the key features of the graph. By the way, when WebWork asks you to find out like what area would show you all of those things, you know, when you've had to do those intervals before on the graph, you basically want to be able to see all those points. So if I zoom in and I don't see all of my critical points, well, then that's not a very helpful graph, is it? So that's why I would zoom it out, and I would really want to just see the key features. The parabola of the parabola are going to be the x-intercepts, y-intercepts, and the vertex. Okay, so go ahead and take a moment to sketch that graph on your paper.